Well, again, thank you for inviting. I'm pretty excited to be presenting you the new Passivhaus City Hall in La Pêche. So a brief summary of the presentation. So there'll be a brief introduction. I'll present the project team. Then I'll talk about the integrated design process that we did for the project. Then I'll go through the concept, the proposal refinement. I have some construction site photos, and then lessons and opportunities. So it all started here in January 2021 with this press release from the municipality of La Pêche, which stated that the new city hall is an opportunity to propose a demonstration model in ecological construction that would become a symbol and a representation of the municipality's integrated approach in sustainable development. So they were looking for firms, for architectural firms and engineering firms that had some experience in energy efficiency applied to buildings, wood construction, concept and certification such as net zero and Passivhaus, LEED, and others. And the energy target was to be 25% superior to applicable norms. So we thought we could do much better than that. Did you see La Pêche? So La Pêche refers more French to an activity than to a town. So actually very few people knew La Pêche. I didn't know La Pêche before we actually started working on the project. La Pêche is located about 30 minutes north of Ottawa. The village core goes back to the first settlers from 1825. Most of them came with the development of the forestry industry. The Francophones came from Lower Canada and others came from England, Scotland, and Ireland. Many of the town's names were inspired by York County in England, amongst Whitmasham, Altfield, Wakefield, Fairtown, and Rupert. So these photos shows they're from the 1900s, and they show the main street and original hotels with their generous terrace and balconies. You can also see a photo at the bottom of the log drive on the Gatineau River. So the municipality of La Pêche was officially born in 1975 by the grouping of Wakefield, Altfield, and Saint-Cécile de Macham. The region is also well known for its covered bridges, one of which stands directly in front of the site chosen for the project, on the Chemin du Lac Philippe, which is one of the main access to the great Parc de la Gatineau. So this is the Gendron Bridge. It was built in 1915. It's in Wakefield. And 3 years later, actually it burnt down in 1984. And 3 years later, a volunteer committee proposed rebuilding it. So they rebuilt it, and their goal was really to rebuild it to the original, and then they reserve it for pedestrian and cyclist use. And the new bridge was inaugurated in 1998. So it is quite it's a nice and a rather impressive structure in the landscape, to say the least. There are some interesting initiatives in the region. That one is an on-demand transport, which apparently is quite popular and efficient, and it's a great success in the region. So it's an interesting initiative. Also, the co-founder of the Canadian Passivhaus Institute and pioneer, who doesn't really need presentation, Malcolm Isaacs, is a local resident, and he actually taught me the basics of Passivhaus back in 2016. Now, the mayor of La Pêche, Guillaume Lamoureux. Guillaume is a very smart and open-minded individual. He's very much aware of the solutions to help tackle climate change. Environmental responsibility really is at the core of his administration, and his vision on sustainable development relies on a balance between a prosperous economy, community solidarity, and a healthy environment. So the project team, so BGLA. So we're based in Montreal. We have offices also in Quebec and Sept-Îles. We have quite a bit of experience in wood structure. This is the Institut du Véhicule Innovant in Saint-Jérôme. This is the same project. So we actually worked with some passive solar solution. Like you can see the sunshade here. This is an office in Gatineau. That's the headquarters for Ed Brunet, which incidentally is the general contractor for the project of La Pêche. This is a school, the Fernand-Séguin School that we did a couple of years ago. This is our proposal, finance proposal for the Lab École in Shefford. And temporary sort of installation, that's an event in Quebec City, Evenement Spot, which we participated into. This is the original concept of the net zero Varennes library, which was it was actually a concept for a CLT building. And this is the Saint-Calixte refuge, which was mentioned in my bio, which is also a Passivhaus, all CLT build. Actually, it's not Passivhaus, but it was designed with passive solar principles in mind. And this is a project, this is a concept for a project in Newfoundland, which I did along with Malcolm Isaacs in Newfoundland. It was also to be a net zero resident, but unfortunately it wasn't built in the end. The client was decided to go ahead other ways. This is the team at BGLA. So Martin Brière, Dominique Laroche, Valérie Lépine, Tristan La Liberté, Dany Lemieux-Philippe, Camille Debruyne, and Janie Tran. Our structural engineer, Thibault Lefort, Anna Chiari, Marc-André Parsons, Michael Payette from Lateral in Montreal, and Pajot Morel for mechanical, electrical. So there were 2 offices involved, the Montreal office in the design and the Gatineau office in following up with the design and construction supervision. We also had the Passivhaus consultant for this project, so Malcolm Isaacs and Jim Iredale. The certifier, Dave Fraser from Peel Passivhaus. So we did an integrated design process for the project. So we brought together the users and professionals for this process. There were 10 persons for the municipality, amongst which the mayor, Guillaume Lamoureux, and 12 professionals. So the first IDP building, IDP meeting, we talked about the site and sustainable development. So the site for the new building is located 2 kilometers east of the current City Hall, and it's right in front of one of the main access to the Gatineau Park. It is on the north side of Provincial Road 366, which is a very good setting for an open, very transparent and welcoming south-facing facade. A few photos. So this is the eastern border looking south. This is actually, I'm actually on the building site, looking south again. You can see the covered bridge in the distance. This is from the Chemin du Lac Philippe, looking towards where the building will be. And this is a view from the east on the provincial road. So this is really like the main views for the people coming into the municipality. So into more details, there are 4 existing access to the site, and the idea was not to create a new one. The prevailing winds are from northwest, and you can see the summer and winter sun path. So we prepared a site map for the participants, in which we included all built and natural elements that needed to be placed on the site. So we split the 22 people into 4 teams. This is the input from team 2. Overall, we actually did this on Miro. It was the beginning of the pandemic. And so we were working on the Miro platform, which is actually quite nice for this kind of work. So overall, most teams located the main pieces in a very similar way. There was a logic to this that, you know, everybody came together as they were playing with the pieces, and they were commenting live on the Miro platform. So with this exercise, we quickly came to a general consensus about building placement and orientation. The second exercise was to weigh between the different sustainable development elements that the client had identified. So the participants were invited to vote on 3 elements that were most important to them, placing them in order, number 1, number 2, number 3. So the winner of this exercise was natural light and wood structure. At the second IDP meeting, we presented actually our Passivhaus consultant. They put together a video about Passivhaus, which was a really great summary that explained where it comes from, what it is made of, and a vision also for what place it might occupy in the future. Previous to that second IDP meeting, we asked the participants to share with us a building they like and why. So as you can see on the slide, there were a lot of different projects in terms of style and scale, and also some surprises, like the mayor voted for the Oslo Opera House, which is a great building. So that kind of brought some pressure on the design team. This is the program that the client gave us. It is summarized here. So there was to be a lobby and a reception and waiting area, public services counter, 27 workstations, 2 meeting rooms, 2 multi-purpose rooms, and common spaces such as washroom and a kitchenette, for a total of 1,417 square meters. For the next exercise, we prepared 4 very simple plans with block diagrams. So the participants were invited to comment the different plan layouts and add their own ideas. We also asked them to answer 3 very simple questions. So what they like, what they don't like that much, and what they are questioning. So then we went on to working more on the concept of the building. This is one of the first sketches of a section through the site. So you can see how the site slope towards south, which is a great setting for having the building kind of sitting on a slight hill and overlooking the Parc de la Gatineau hill. So really the site was really well chosen. The view to the side is beautiful. So the idea was to open up the building towards the south with a roof sloping up from the north, which you can see in the section. That would allow us to have a very generous opening on the south side and for solar gains, and also have a reduced thermal envelope on the north side, which helped us with heat loss. So this is one of the first 3D models showing these principles. So then we had to test this in PHPP. So the first PHPP run, we actually did a quick concept, a simple proposal to be tested in PHPP, which you can see here. Then our PH consultants, they proposed a first wall assembly, which was made of a main wall of a 2x8 filled with insulation, 2 layers of 1.5 wood fiber insulations, wood fairings, and a cedar siding outside. On the interior side, we have an interior wall cavity of 1.5 inch filled with insulation. The first detail section. So on the left-hand side, you see the insulated slab with the wall sitting aligned on, and on the right-hand side, the building plan detail, which I previously described. So these are the first PHPP tables. So with this information, at this point, it seemed like we were to be heading in the right direction. So then we went on with the concept and some inspirations for carrying on with the building design. So as mentioned earlier, there are quite a few covered bridge in the area. This shows a few different covered bridge structure that we can find in Quebec. The one pointed with the arrow corresponds to the bridge facing the City Hall, which you can see on the right-hand side. And in the end, we really wanted the building to echo the covered bridge structure. You'll see later how that translated into the design. So a few buildings really inspired us for the design. This is one of them. It's the Southwest Library in Washington by Perkins and Will. So it's an exposed sawtooth roof with generous glazing, which open up to the views. A second inspiration is the community center in the UK. There's a series of inclined roof here, and it creates a friendly and dynamic facade with lots of wood. So we developed two different scenarios. This is the first one. This is the ground floor. So we have a double height central hall access on the south side for the visitors. And this is at number 1. And at number 2, we have a secondary entrance for the staff at the back. It's not at number 2, actually. It's more on the north side, like close to the elevator. We then have a series of open and closed offices on the south. We have central WCs and an archive room and multi-purpose room at the back. On the second floor, we have an open area on the south side for workplaces. And in 1 and 2, we have sort of like pod-like offices, which you'll see better in later in the presentation. So we also have the mechanical room at the back. We have a multi-purpose room in 8, electrical and server room in 3 and 5, and an additional meeting room in 4. So this option shows a single slope roof to the back. This is a view from the second floor of the central hall. We also worked on the second scenario where we shifted the plan from the central hall space. So we have this option was to place the entrance on the orient the entrance on the east side from which most of the visitors would come. So the layout is pretty much the same as the first option I showed. On the second floor. This is also where we started looking at using the CLT panels for creating long spans. So this is, you can see a wooden curtain wall on the south side, a glue lamp, more closed facade on the north side. And these are the CLT, the inclined CLT panels that would allow us to create a free span on the second floor. And this is the same view from the second floor looking south. So then we look at the pluses and minuses of the two options. So for the first scenario, there was the simplicity, the single slope roof, rational aesthetics, and also a minimal surface area for the roof. On the minus side, we could say that simplicity, single slope roof, and rational aesthetics could be a minus. You know, it can be a bit boring. The second option had free span roof, interior layout flexibility because we have no columns on the second floor, more open views to the south, and a more contemporary vernacular aesthetics, which echoes to the covered bridges and also increased solar gains, and some aspect of innovation because the roof was quite an interesting structure actually by a structural engineer, which goes back to the actual reinforced concrete structure of the beginning of the 20th century. The CLT is actually pretty good for working in 2 directions. So it's a little bit similar to what we saw in earlier reinforced concrete structure, but with wood. And on the minus side, obviously we had some increased surface area for the roof with this option. So we just wanted to see how much the sawtooth roof impacted on the building envelope area. So we did a little calculation and we came up to about 9% increase in total building envelope with the sawtooth. So we thought we can deal with that, we can afford that. So we went ahead with these two views actually convinced us, both us and the client, that we should go with the sawtooth roof, which really had a much better look in terms of design and also allowed us to increase the solar gains from the south. So these were the first sketches for how we were to insulate this sawtooth roof. So on the left-hand side, we first thought, well, we could actually build a secondary structure and create a flat roof and then maybe fill the void with cellulose insulation and something like. And then the second option was more to work with a sandwich roof. So in the end, we went with more the second option. And the second option, the second sketch also shows we knew that there was going to be snow accumulation on this roof, but it could actually help us somehow with the insulation value in the winter. So this is a more detailed building section of the roof. So we have a metallic roof, a ventilated metallic roof, and then we have 3 layers of rock wool insulation, 3 times 6 inches. Then we have our vapor barrier and the CLT panels with the interior face exposed. Design pH. It was a very it's a great tool actually to test a lot of iterations. So I'm going to go through these quickly. It's just to show how very quickly we can figure out what works, what doesn't. You know, this was a test without the sunscreen, and we realized that it really helped with the space heating demand. But on the other hand, obviously, it made probably the air conditioning too difficult. So this was not an option. So we did all sorts of iterations of the design so that we could come to something that we liked and that worked well. So I'm just going to flip through these quickly. I'm sure everyone around is very familiar with these tables. So the interesting figure is, I think, the annual heat demand. So you see how it varies with all of the different scenarios. So in these scenarios, we were above target. So we went on and tried different things, and it goes up and down. Just go through these quickly. So it really is a great tool. You know, in the end, it was a matter of the actual size of the sunshade, which helped us reach the right balance between heat gains and heat control, so that air conditioning wouldn't go into the roof. These are the structural, the concept structural drawings. So it's a glulam post and beam structure with CLT floors and CLT for the roof as well. So I'm just going to go quickly through these. But the idea really was to try to echo the covered bridge structure. So all the bracing are left exposed inside. So it's sort of a wink to the covered bridge in the region. Now the mechanical layout concept. So we have hydronic units with local control in every room. This is the ground floor. On the second floor, it's the same principle. On the right-hand side, you see the little office there. You see it better in a drawing coming up, but they're like pod-like little offices. So all the ducting, they actually go on sort of a mechanical roof above these little pod-like things. So yeah, that was the strategy. This is the mechanical room with the sway gun unit. And this is pretty much the final site plan. It shows the building parallel to the main road with a terrace at the south and a series of water retention basins on the south. The staff parking is on the east side of the building, and no, the staff parking is on the north side and the visitors parking is on the east side. Schematic plans and sections. So that shows how the blue line is the vapor retarder. So it's our continuous vapor retarder, and you know the overall simplicity of the building section. I guess really made the achieving the air tightness target more easy. Now the final building plan. So in one, we have the main entrance with the central hall. In two, we have open offices for urbanism. In three and four, we have meeting rooms. In five, we have the archive room on the north side. In 6 and 7 is a multi-purpose room, which is also the council room. In 8, we have neutral gender WCs and more offices in 9. 10 meeting room in 11, and at the bottom you can see the seating plan. So the intention really was to hide all of the ducting, and at the same time we wanted to expose as much as possible of the CLT ceilings and beams and glulam beams. So in the plan at the bottom, the white pieces are where the actual ducting goes, and the remainder is really the exposed CLT plans, which we were able to left pretty much unobstructed. The second floor plan. So in 1 and 2 is the pod-like offices, which you'll see are better in the building section later. We have the washroom, and there's also a shower in 11, and in 10 it's open area offices. We have a multi-purpose room in 9. The mechanical room is in 8. The kitchen in 7, 6. The server room, a lounge room in 5, and another meeting room in 4. So this shows the actual interior elevation, the final interior elevation of the building. So yeah, I guess we can see how it really echoes the covered bridge structures. A lot of, you know, as I was saying earlier, all the bracings are left exposed. So we can see the elevation. So we have 40% opening on the south side, 16% opening on the north, 20 on the east, and 10% on the west facade. This is the main reception area with the double height central hall. And this is where you can see, can you see the cursor? So these are the pod-like offices as I was referring to earlier. So they're actually like little boxes in the space, and the roof runs freely above them. So it really, you can see on the left-hand side at the bottom here, it really makes for a very interesting space, and you can feel these long free span with the CLT panels, which is quite nice. This is a view from the second floor hall, looking south towards this is the actual view of the Gatineau, Parc la Gatineau Hills. This is the main facade. And this is the final building section. So again, we had to do a lot of iterations to finally get it right. So we can see how the slab, the insulated slab is aligned with the walls. And there's a very simple air tightness path that we can see in this section. So the insulated walls are actually screwed from the outside onto the glulam structure and CLT structure. I have a few construction site photos. But first, the general contractor is Ed Brunet from Gatineau, with Martin Neuville, André Picard, the site superintendent, and Mamadou Bobosso, the project coordinator. This is a photo of the insulated slab being before it was poured. There were a lot of equipment and reinforcement. I was really quite impressed, as I often am when I go to construction site. I find that our job is easy when I see how complicated it gets on site to actually put everything together. So this is the building structure. This is the view towards the Parc de la Gatineau. You can see in the center the little covered bridge. We can see the wood fiber boards panels. And I think this photo shows well how actually I was really well put together. There was a lot of care in making sure that everything was tight and nicely built. These are the window openings before the windows were installed. The north facade. A view from the second floor with the south facade on the right-hand side. The radiant floors at the perimeter were being installed. That's the SIGA air barrier. And this is quite a recent photo. The sunshade. And the last photo, that one was shot yesterday, actually. So they're starting to put together the spiral staircase. So lessons and opportunities. I call this slide PHPP sensitivity because you'll see throughout, I'm going to go through different iterations as we refine the design and play with the building parameters. You know, the space heating demand goes up and down, and it can be a little stressful, but you know, and last year we were at the same time we were doing all right, but then it was the construction holidays, and the building certifier sent me this email saying that there were some bugs in how the actual envelope was being calculated in the PHPP. So all of a sudden we end up with a 19.8 kilowatts square meters per year as the space heating demand. So we just, you know, I freaked out a bit at this time, and I thought, okay, what can we do? What can we do to actually reach a target? So I proposed a few things: increase insulation on the inside, because we only had, actually at the beginning we had 38, then we increased to 51, and then we tried increasing to 89, and then I proposed to be a little bit less conservative with thermal bridges, because we didn't do all the thermal bridge calculations, so we went with very conservative values. So we thought we could, you know, tighten that a little bit. Then we tried reducing the window areas on the north, but the windows were being built at this time, so maybe it was too late for doing that. And then we could modify also the G value for the windows if it wasn't too late. So this is our building certifier. So we sort of figured out that if we increase the air tightness target to 0.4 instead of 0.6, and we would eliminate the exhaust range from the hood, then we could go back to reaching the target. So we did that. So then the PHPP process went on with, you know, refining the building modeling in PHPP with the certifier. So right here we're exactly at 15 for the space heating demand. Goes up a bit, goes up a bit again. So like we're just very close to the target here. So it was a little bit difficult. We did some other modification. We had the final specification for the the spacer in the glass, which made a big difference. And then on April 19, we did the first blower door test, and we did really good. We did 0.25 air change per hour. So all of a sudden, with this result, we could bring the space heating demand down to 14.33. So we're in good shape right now for getting the certification. The building certifier is finalizing his review. So in conclusion, a few months ago, there was the COP28 in which, you know, we were sort of presented with hyper technological gizmos for the future, which really makes me go, oof. And, you know, when I look at such apparatus, I go, you know, what the hell is that? So I think that this is a much better way of foreseeing the future, you know, working on energy efficiency. And this is, I think, a better way forward than trying to solve the problems with technological gizmos. Thank you very much.
Thank you so much, Dominique. That was awesome. I have some questions. I don't know, does anybody else have any questions for Dominique about the presentation? About the process? I don't see any questions at the moment. Hands? Anybody? I especially enjoyed the part where we're at the very last minute, suddenly the building wasn't meeting Passivhaus standards, because that is that's a pretty, in my experience, that's a pretty normal process. So it does, the numbers go up and down quite a bit as you're working through the building, and air tightness does make such a big difference. But yeah, it's a beautiful building, and we're getting a lot of thanks, and that was great. Any other questions from anybody, or any other comments that anybody'd like to make?
Yeah, I'd be curious about the glazing that you put in there. Where did the windows come from?
The windows came from Germany. They came from FDV Stahl, and it was a little bit difficult with coordinating all the parameters, and but in the end, you know, the product they delivered is great, and the general contractor was able to work around some German instructions, and they actually also sent someone to La Pêche. FDV Stahl sent someone to La Pêche to supervise the beginning of the installation. So it worked out well in the end, but I wish we could source these windows in Quebec, really, or elsewhere from Canada, but there are so few manufacturers. Someone in the West was also considered, but in the end, FDV Stahl, the German manufacturer, was chosen.
What was the complication in finding the Canadian manufacturer, the fact that they were made out of wood, or was it just the size of the windows that made it complicated?
It's not the size, it really is the fact that we wanted to go with wood windows with aluminum on the outside. Aesthetically, that's really what we wanted. And I understand that wood windows are pretty much the best for Passivhaus, or, you know, really, really good. But it wasn't a size issue, no.
Yeah. Congratulations on 0.25 on a building that size too, by the way. That's amazing.
Thank you. I
That is amazing.
You know, congratulations.
Yes.
It should really go to the general contractor, you know, the site superintendent, André Picard. He really became passionate about Passivhaus, you know, and he really took it, you know, took great care. He actually, you know, he gave us some very good advice on how to actually improve our construction details. So we made some slight modifications to what we had planned, and you know, he was very smart and very careful throughout. So I was super stressed out when we had the blower door test because you know it makes such a big difference. And I knew that we were so tight that we kind of needed a better result than 0.4. So it was very, very exciting when we got the 0.25. You know, I was there and we actually had a bottle of champagne to celebrate. Yeah,
we do have a couple of other questions.
Yeah.
So from Brendan, he wonders what the overheating was like, and the big struggle or the permanent shading. Is it enough?
Sorry, I didn't get the first question.
So what was the overheating like is really the question. So have you experienced overheatings in the building yet? It's not occupied, but are you seeing that there's some overheating in the spring?
The building is not occupied, so the systems are not functioning. I'm going there once a month because it's quite a long way from Montreal, but the superintendent told me that it did get warm when it was very sunny. But I mean, I'm trusting that the PHPP and the calculation and the geometry we did for the sunshade will work out. It seems like it will. I guess we'll see over the next year once the building is occupied, but the mechanical engineers are not worried about that either, the certifier either. So we'll see, but hopefully it remains, you know, within the range and comfortable. But it looks like
Is there active cooling in the building?
yes,
There's active cooling. Yep.
yeah,
Okay.
yeah, there's active cooling. I think it remains required, I believe. Yeah.
Brendan's also asking, did the multi-slope roof model out better than the standard slope roof? It didn't seem like there was much of a difference or too much of a difference.
Sorry, which
So for the multiple angles in the roof, as opposed to the just a single slope roof, which modeled out better?
The single slope roof modeled out better, you know. There wasn't such a huge difference, and that's why we decided to go ahead with the Satud. But there were some discussions in the design team about this because it's not a very intuitive thing to add a building envelope to a passive house building. But in the end, it worked out in the modeling. You know, we had to add a little bit more insulation here and there, sort of compensate on other aspects of the building to reach the target. But there wasn't such a big difference actually between the flat and the Satud roof.
That's very interesting. Matt is asking what the main drivers for going with the CLT were.
Carbon sink. We want to have it's a very energy efficient building, as you can understand, but it's also a very low carbon building, and it was also one of our aims. We wanted it to be both because carbon sink is, you know, it's as important as energy efficiency. So that's what drove the choice for massive wood, and also the CLT for the roof. As I mentioned in the presentation, the fact that we can work with CLT a little bit like with reinforced concrete, you can do interesting shapes. So using the CLT panels as beams with, putting them inclined. Our structural engineer got really excited when we had this idea. I thought, wow, this is a great use of CLT, let's do it. So that's what drove the choices.
Was there a full embodied carbon analysis done for the building? I know we're talking about carbon sink, but for the importing of windows and importing of CLTs and that sort of thing, was the whole building looked at that way?
It wasn't, but we might do that analysis afterwards because it's important. The CLT came from Shibugamo, Nordique, so it's not actually that far from building site. But the windows came from Germany, so we didn't actually make the analysis for in terms of life cycle, but obviously, you know, it would be much better if we could source them in Quebec. And I hope the industry will step up and start, you know, getting certified products here and also more across Canada, because to my knowledge, there are still quite just a few wood windows manufacturer in Canada that can provide certified windows. So
Yeah, I think it's all about it's about the market and demand, right? So
Exactly.
we do have a question from Michael about the cost difference from conventional construction, and I'm going to assume Michael means if it was a steel building and it was insulated, we have to say it would be insulated to the same degree. Was that analysis ever done?
We didn't make the direct comparison for the structure, but we did at the same time, like we do a lot of school projects, which are similar quality buildings. And at the time we received the quote for the City Hall, we also received some quotes for schools, and they were very, very similar. They were actually pretty much exactly the same. So,
wow.
Yeah, so it was impressive. At the same time, it's still an expensive building, just because of, you might have heard that in Quebec there's I think it's similar across Canada, but there really is a surchauffe. There's just too much building work going on, so prices went up drastically during the pandemic, and ever since now it's sort of stabilizing. But when we went out for tender for this building, it was pretty much at the top of the building surchauffe in Quebec. So all projects came out very, very expensive. So this one was not different, but it wasn't actually more expensive than conventional school buildings.
Has anyone done an analysis over the for the payback period and about the crossover time when this building will be running in terms of its costs for utilities at
Yeah, we had an analysis done by the mechanical engineer for the building consumption, and they estimated that a standard building would cost about 25,000 a year to heat and air condition, and our building is 9,000. So it's roughly a 65% decrease, better performance than a standard building. So
okay.
I mean, 16,000 a year, you know, it takes many years to, but I mean, the payback period to, you know, if I think we can build Passivhaus for the same price as standard buildings, you know, the fact that simpler shapes are the way to go, that reduces building cost in itself, mechanical systems that can be reduced. If we make smart design decisions, this project shows that we can build them for the same price. So
that is awesome. That's awesome. Michael Mueller has just pointed out that Passivhaus has only been in Canada for 14 years. Is that right? It seems like it's been longer, but is there any other comments, questions from anybody else?
The first building in Canada that meets Passivhaus was the one at Whistler at the Olympics.
Right, at the Olympics, right?
That's only 14 years. I know, it's amazing.
It's brand new. Yeah, it's a very short time.
Yep. That's great. Okay, any other questions or comments from anybody? It was an excellent presentation. Really enjoyed that. Love the process that that you went through in order to have a pretty beautiful and successful project. Excellent.
Thank you.
Thank you. Fantastic.
Thank you for the presentation.
Yeah, thank you a lot.
Yeah, wonderful.